Hey folks, thank you very much for coming. My name is Ben, and I'm going to share a story about delivering data faster. The story will help us better understand when we need real-time data and when we don't. So let's get started. Let's see if I can do this the right one, right? Ah, cool, thank you. Magic. So our story starts here when stakeholders start asking for real-time data. In our case, it was the sales team who wanted us to send some internal events to Salesforce so they could reach out to sales leads as soon as possible. But our data infrastructure was entirely based off batch pipelines. We were running them on a daily or an hourly schedule. So in this presentation, I'm going to explore what we data professionals can do in this scenario. But before I do that, I want to set a little bit of a context for this talk. I think most, oh, sorry, can you all hear me? This feels weird. Most of us who work with DBT, we work in business analytics, or if I want to use the traditional term, business intelligence. And our most important goal is to enable others to make better decisions with data. And they typically consume the data from the data warehouse in the form of spreadsheets, dashboards, or SQL queries. And we also push data to third-party systems. And that process is known as reverse ETL or data activation. But we typically don't serve data to the users of the company. They are not exposed to the data warehouse. Why is this important? It's important because users, at least at most companies, are prioritized over employees. And we can't make them wait, right? At least we don't want to make them wait, even just for seconds. So for user-facing applications, I would say that we do need real-time data, almost always. But that's typically not the case in business analytics. Hi-Fi Labs created a poll on LinkedIn asking all of you how frequently your dashboards are updated. If I remember correctly, please correct me if this is complete rubbish. I think more than half of you said that they are updated once a day or even less frequently. And only 10% of you said that they are updated every 15 minutes or more frequently. So that's pretty much in line with what you'd expect based on this. Okay, so considering all this, allow me to introduce a not completely arbitrary reference point of what we mean by real time. And that would be an end-to-end pipeline latency of 1 minute or less. And that's because real time means different things to different people, depending on the situation, right? And I could go into very boring, detailed discussions about semantics. I think I have a couple of more interesting stuff to share with you today. And I'm sure that this guy in the picture would happily agree that 1 minute is absolutely real time, no questions. A couple of words about Hotjar. I work at Hotjar, by the way. I'm a data engineer, not very good at introductions because I completely forgot to introduce myself. But you have to know a couple of things about Hotjar. We are basically a typical DBT customer. A small or maybe mid-sized tech company. All our infrastructure is in the cloud. And we have a fantastic data team of around 20 people. But only one person is dedicated to data infrastructure. And maybe 3 more of us work on infrastructure-ish projects occasionally, but our capacity is finite. So we have to be really selective about what we build and support. And companies like Hotjar tend to gravitate towards something that's often called the modern data stack. And that's because the modern data stack enables companies to build business analytics infrastructure with very little upfront investment. But even more importantly, the modern data stack enables basically anyone who knows how to write SQL to build ELT pipelines. They don't have to know anything about serialization or cloud computing, they can just focus on the business domain and deliver value. That works really, really well at Hotjar, I must say. Speaking of Hotjar, this is our version of the modern data stack. I don't think the specific tools are super important, so I'm not going to go through them. We could be using Airbyte instead of Fivetran, or there are like 6 million other combinations of tools. But the concepts are pretty much the same, or at least similar. And one of those concepts is that these tools were designed to run batch pipelines, typically on a daily or hourly schedule. At least that's what we do with them. But what if we need the data faster? Sometimes real-time or near real-time use cases pop up, or stakeholders come to us with these use cases. I already mentioned one briefly at the beginning of this presentation. We might want to reach out to sales leads as soon as possible. Or we might want to observe product metrics or key business metrics immediately after a product launch. Or we might want to send marketing messages to our users when they are the most receptive to them after taking certain actions. So these are all based on true stories at Hotjar. But I think that we can learn the most from the first one, the sales leads use case. So let me share a little bit more detail about that one. Apparently, if we could reach out to sales leads within 1 minute after they created an account, we could drive up conversions by 400%. These numbers were supported by studies and super serious Harvard Business Review articles. This looked like a huge opportunity if you could just make this pipeline faster. The pipeline wasn't complicated. We had some internal events, we enriched them and pushed them to Salesforce. And there was more business logic in Salesforce determining who is a sales lead and who is not. So overall, it looked like, I'll just keep this. It looked like that we had some very strong real-time and near real-time use cases. And that started something I call excitement-driven development. This is where I was a year ago. That's literally me. When I started exploring stream processing, and there were just so many tools out there, and it was very easy to get excited about something new and shiny. Most of you are engineers. You know what it's like, right? I mean, look at how stunning those logos are. Pink squirrel with a rainbow tail. Okay, I have to go back to on topic because 20 minutes is my limit here. So these are great tools, built by super smart people, battle tested at huge companies. One thing we realized early on is that we needed a real-time analytics, a streaming analytics architecture that was event-driven and pushed processed events to Salesforce. So for this specific use case, we didn't need a real-time data warehouse, which is a shame because it sort of ruled out some of the great tools like ClickHouse or Apache Pinot. That Pinot's logo is a glass of wine. So that's one of my personal favorites. Around that time, Hotjar started using Apache Kafka as a message bus. So we decided to jump on the bandwagon and we started building our streaming analytics capabilities based from tools in the Kafka ecosystem. But building all this took a lot more time than what we expected. First of all, we had to build a completely new infrastructure. We had to maintain it. It was completely different from the usual batch tools. It had different failure modes. It used different underlying technologies. Like most of the tools in the Kafka ecosystem are Java-based. And far fewer people speak Java compared to Python in the business analytics world. As we learned from the previous presentation, besides SQL, the second lingua franca is definitely Python nowadays. We also had to figure out how to fit this whole thing, the streaming infrastructure, into our existing data infrastructure. We had to figure out how streaming and batch could sort of live together, and we had to reconcile the differences between them. We also had to learn new concepts related to time, ordering, late arriving data, delivery guarantees, and everything was event-driven, which was completely new to us. And this just sort of made our whole architecture and transformations just a little bit more difficult to reason about. It uses some of the mental bandwidth of both engineers and analysts. Complexity, that was another challenge. If you want to build a pipeline with multiple stateful transformations on the top of each other, it's trivial in dbt or in any batch framework, really. It gets really messy really fast in the streaming world. Finally, we were running the risk of creating silos, both knowledge silos and data silos, because democratization, which is, in my opinion, one of the killer features of the whole modern data stack, that's not so easy to achieve in the streaming world. And we are still trying to figure this out today. We might end up writing a dbt connector for the streaming framework, stream processing framework we are using. Not sure if that's a good idea, though. But anyway, we have to make democratization sort of work. Otherwise, we will end up with business logic embedded in relatively complex systems that are only understood by a few people. And we are a small team, so key person dependency is a big problem. We go on holiday and then there's no one who knows how something works. Okay, let's have a look at the benefits of stream processing compared to batch. And in order to truly understand this, we have to assume the role of a detective. We have to ask the right questions. We have to understand how the real-time data would be used, what actions or decisions would be made based on it. Would it be a completely automated process, or would there be humans involved? Because if humans are involved, we are inherently slower. Even more importantly, we have to understand what happens if the data is delayed. Does it become completely useless? Does it become a little bit less useful? Or maybe it doesn't matter if it's late. But if it doesn't matter when it arrives, do we really need real time? Probably not. And finally, we shouldn't forget that it only makes sense to build real-time pipelines if all our sources support producing and sending data in real time or frequently enough. Otherwise, that part will be a bottleneck, and it doesn't matter if we process it real time, if it arrives in hourly batches, right? Okay, back to our story about Salesforce. Believe it or not, turned out that all the evidence, all the super serious Harvard Business Review articles supporting the 1-minute latency requirement for this pipeline, so those were from other industries. And there was absolutely zero Hotjar data or research supporting this. Furthermore, sometimes humans had to be involved before we reached out to sales leads. Not that surprising if you think about it. But to make things worse, we realized that in order to enrich the events before we send them to Salesforce, we had to call a third-party API. And sometimes that API responded in 3 to 5 minutes. I can't show 5 because both of my hands are busy. 3 to 5 minutes. So that was our bottleneck. We couldn't go any lower than that, because if you have to wait 5 minutes for that API, then your pipeline will take at least 5 minutes. After some internal discussion, we had a new requirement. We wanted to get the data to Salesforce in 10 minutes. I can't show 10 either. So back to the drawing board. We came up with a new idea. Maybe we can make the modern data stack meet this requirement. In theory, all these tools support running every minute, right? So we hope to achieve an end-to-end pipeline latency of around 5 minutes. But in reality, we struggle to achieve even the 10-minute requirement, at least not consistently. The reason is that there are just too many things that can go wrong here. High touch, which is one of our, which was our reverse ETL tool that actually sent the data to Salesforce sometimes took a couple of minutes to sync the data if there was more data than usual. Sometimes it skipped a sync. And it's not an open source tool, so we couldn't really investigate, and we didn't want to reach out to support with this because it's really not meant to be run every minute, I think. Redshift was another one. Sometimes the load of the cluster was higher than usual, and queries that usually took a couple of seconds took a couple of minutes. And the API I mentioned might take a couple of minutes to respond, and these delays just keep adding up throughout the pipeline. And boom, you are over 10 minutes. So more investigations, experiments, and we concluded that, and this is not just related to the Salesforce pipeline, but we couldn't really guarantee any latency lower than 15 minutes with this data stack. Now, there's a warning in the screen because I know that these numbers heavily depend on the specific tools that we use. And you might say something like, okay, we use Snowflake and we Snowpipe and dynamic tables, these numbers would be different. I know. But actually, the numbers in this presentation don't matter that much. Actually, I'm pretty sure that everything here will be completely obsolete in the very near future. But the message I want to sort of reiterate here is that we should know the capabilities of our own tools or existing tools before we start evaluating new ones. That's a mistake we made. You should learn from that mistake and not repeat it. You can make your own mistakes and come and give a presentation about them next time. Okay, this is unrelated to the Salesforce story, but I wanted to show you this example. If we want to make our pipeline run faster, but we don't want to change the infrastructure too much, we still have a couple of tricks up our sleeves. For example, we might be able to identify a bottleneck in the pipeline, which can be a stage or a tool, and replace that with a faster version. In this example, we are replacing a Fivetran connector with a custom Python script. Now, we only do this for that one source where we want to have a lower latency. And we can keep using Fivetran for everything else because we don't want to reinvent the wheel and write custom integrations. At least I don't. So this works, but it increases the complexity of our architecture. Observability becomes a little bit more difficult, and democratization. All the warnings I said earlier when I talked about stream processing, they apply to a certain extent. So this is not a silver bullet. It can be still cheaper than implementing a whole streaming pipeline. So we should look at this as another tool in our toolbox. Okay, back to our Salesforce story. Final chapter. More discussions with stakeholders, and it turned out that we don't need to speed up this pipeline at all. 1 hour is just fine, because there's no tangible benefit of speeding it up. Now, we did have, and we still do have, other real-time and near real-time use cases at Hotjar, so we continued building our streaming capabilities, but for this specific pipeline, we didn't have to change anything. But we learned a lot. That's the most important thing. Okay, what can we learn from all this? Do we need real-time data or not? Well, the answer to this question is the same as the answer to every single computer science or engineering question ever asked. It depends. And it will sound like a cliche, but we have to understand the requirements of our stakeholders. That's a good starting point. Now we have to understand the capabilities of our existing tools and the tools available in the market, and use the right tools in an optimal way to meet the requirements. I guess the main message I want to reiterate here is to learn from our sort of mistakes and be aware of the shiny object syndrome. And the key takeaway is this: doing more with more is great, but doing more with less can be even better. Knowing your tools well and making them deliver more is one of the most valuable skills in engineering. In my personal opinion, it's one of those things that make data engineering a really exciting career. Thank you very much for listening to me.